Let's go to page 299, and this is lesson 25.6. And this lesson is on mixing it up. So in some problems, especially the criteria are mixed. So like this one over here, then what you need to do is you have to list up the cases, and then you have to figure each individual cases and you add them up. So in this problem, it says, in how many ways can Antoinette give 1 mm each to 2 children if she has 3 different red, 4 different brown, and different 5 different tan ones, and 2 children insist upon having MMs of different colors. Okay, so what you need to do is for this one, okay, you have 2 children, okay, and you have the MM 3 red and 4 browns, and you have 5 tan. So in this case, you need to go and they have to have different colors, right? So you have to list down the cases. So you can have the red, brown, or you can have the brown, red. You can have the red, tan, or you can tan, red. Then you can have the brown, tan, and you can have the tan, brown. Okay, so those are all the combinations. Then after that, you have to figure out each one. So this will equal to 3 times 4, give you 12. And this is 4 times 3, give you 12. And this one is 3 times 5, give you 15. And this is 5 times 3, give you 15. And this one is 4 times 5, give you 20. And this is 5 times 4, give you 20. Then after that, you add all these cases together, you get 94. And that's it. So again, when the criteria, when you have mixed criteria, you need to go and list down the cases and figure each individual case, and then you add total together. Okay, let's go to next example. Let's go to page 299, and let's do example 25-10. Okay, it says, how many odd numbers? So you can write down your criteria. It says odd numbers with middle digit equal to 5, and no digit repeat. Okay, and it's between, so between is not include. Okay, so you're looking at 20,001 to 69998. Okay, so for this one, again, you have to write out your cases. Okay. And for this one, the odd digits are 1, 3, 5, 7, 9. Even digits are 0, 2, 4, 6, 8. Okay, so the middle number has to be 5, so you have only one choice. Now, for this problem, the key number to focus on is the 3. Okay, so if you put a 3 over here, there will be one choice, and this one will be not 3. Okay. Okay, so if the 3 is over here, okay, now this one can have 2, 3 is already taken, 4, 5 is already taken, so you have 6, and that's it, right? You can have a 7 or 8. So these are 3 choices. So after this, so after you figure the criteria, this one has no restriction. Since the 3 digits are picked already, so you got 7 digits left. So you got 7 choices. So after you put a digit over here, you got 6 digits left. So you got 6 choices over here. And so this will be equal to 126. Okay, now over here, again, 5 have to be in the middle, so there's one choice. And not 3, and remember it has to be odd, okay? It has to be odd and cannot be 3, so you got 3 choices. You can have 1, 7, or 9, so you got 3 choices, okay? Then after that, this one over here, we have 4 choices. Because if this is not a 3 over here, so this one can have 2, 3, 4, 6. So you can have 4 choices over here. Okay? So after you put the digits in here, now you can figure out this one. This one has no restrictions. Okay? And the reason you have to do this is because, again, there's a restriction. The 5 has to be in the middle. and this one has restriction because it has to be odd, and this one has restriction because of the boundaries. Okay, so again, you do all the restriction first. Then after that, when there's no restriction, then would be just whatever is left over. So again, there are 10 digits. So you put one digit here, one here, one here. So you got 7 digits left. So you got 7 choices over here. And again, you have 6 choices over here. And so when you multiply, this will give you 5 or 4. And so when you add all this together, you get 630. Okay. Okay. So now let's go to next example. Example 25-11. So how many counting, it says many counting problem can softly change by distinguishability of the object counted. Consider the problem. How many ways can 2 objects be put in 2 boxes? Okay, so you got 2 boxes, okay? And so you got 2 objects. Okay, so I'm going to use the star and the moon. Okay, so you got 2 objects you're going to put in 2 boxes. How many ways can you do it? Okay, well, there are different ways, right? You can have this way. Okay, you can have one each. Okay, and you can have this way. Okay, or you can have this way, right? So there are 4. Okay. Now it's going to be different if the 2 objects are indistinguishable. So if you have 2 of identical objects, then you can either, then in this case you're going to have 2 over here, or you can have 1 each, okay, or you can have these, okay. So in this case you only get 3, okay. Well, actually these are like 2 different boxes, right? Okay, now if the boxes are identical, if you have identical boxes, so if the boxes are indistinguishable and the objects are indistinguishable, then in this case you can only have 2 in one of the box, or you can have 1 each. Okay, so you got 2 choices. Okay. So you have to read the problem carefully and depends on the situation.